revision series. So this is the second chapter for which we are doing the revision series. The chapter is solar radiation, heat balance and temperature. So the revision series is based on your, yes, it is based on your proper NCRT part, and all the pointers are taken from NCRT itself. Just the way NCRT is providing the stories with examples, it's a straightforward on the point notes. So these are best for a revision. Okay, yes. So let's get started with it. So the first point that they've mentioned, that Earth receives 1.94 calories per square centimeter per minute at top of the atmosphere. So this is a factual part, that how much heat the Earth receives. Okay, right. So the next point is why there is variability of insolation at surface. So why there is variations in the heating, like how we could say, as we read up in the previous chapter about the water vapors, about the carbon dioxide, that what they do is they trap up the heat, how they react to the terrestrial radiations or to insolation. So now the question is why there is variation of the insulation at the surface. So they provided us with the idea that how there are at different places there are different heat radiations that we could see, but what are the reasons of it? So they've explained the reason, that is uh, rotation of the earth. The first one, that is the rotation of the earth. Now the earth rotates, as you know, and because of that, like as you could see, like the earth is not the one which is flat, right? It is spherical. So if one part of it will receive the heat, the other won't. So that is one of the reason that we could see that there is the variation in the insulation that is received. Then the second is angle of inclination of sun rays. Now, as this is the example of angle of inclination. Now imagine if this is sun, right, and the now there are two angles that are formed. One is the straightforward, the another one is little slant. So this angle of inclination of sun rays, they also affects the insolation. Now the direct sun rays, this will have a more lasting impact as compared to the slanting one, because the vertical one, there is more scorching heat at this point as compared to the another point, right? Then there is length of the day. Now the length of the day also, now these are the 5 points. Okay, so the third point is length of the day. It also sees up that what all factors, or what all amount of heat radiation, solar radiation will be there. Then we have the transparency of the atmosphere and configuration of the land. Now these two have less influence. So first is the transparency of the atmosphere. Like if we have the transparent atmosphere, there are no water droplets, then there will be more insulation as compared to when there are more water droplets present in the atmosphere. And then there is configuration of the land. For example, if you could see there's the land, empty land, nothing sort of no sort of building and all, tree and all is there. So that sort of land will face more scorching heat, more solar radiations, more insolation, right? Yes. Now factors which influence insolations. The first is the angle of 66 and a half of the earth. So as we know, this angle of the earth is 66 and a half, right? So because of this angle, there is the impact on the solar radiations that we see. Second is the amount of insolation received in the angle of inclination of the rays. Now this is like the first point, angle of 66 and a half of the earth. This is they're talking about the bend, like the tilt of the earth. The second point, the angle of inclination of rays, they're talking about the rays, the manner or the nature of the rays which are receiving from the sun. So how they are different. Okay. And they also explain of the phenomena of the color to the sky, that is, as small of the particles, dust particles are present in the troposphere, and because of that we could see the scattering of light. So scatter visible They scatter the visible spectrum both to space and the Earth's surface. That is why when there is a sunrise or a sunset, we could see that orangish, yellowish uh, clouds out there. That is because of this phenomena, scattering of light, and that happens in the troposphere itself. Okay, then we have the insolation. Yes, just a second. Yes, insolation received. Yes. The installation received, that is, now they are talking about the factual part, that is 320 watt per meter square in tropics, and it poles at 70 watts meter per square, like meter square in poles. So this is how the insolation is received. So it is maximum at the subtropical desert. So this is a small part that you could see, but in NCERT it will be really line by line. This is different. Okay. One more point that I forgot to tell you is about the epileon and perihelion. So epileon is the point, like as you could see, yeah, epileon is the point. Just a second, what they're mentioning? What I mentioned was it? Yeah, this is opposite as I could see. Sorry for it. So just make a correction here. Epileon, because I learned it like for A away and A for epileon. So A, when it is away, like the earth is away, like farthest away, that is 152. So make the correction with this number. 152 should be presented here and 147 at perihelion. Okay, fine. So let's go ahead now. Now we have one of the important point, that is equator receives comparatively less insolation than tropics. Now this is the very important point that it should be noted, because what's the point that we feel that equator receives the the maximum amount of insolation, but it's not right. In fact, equator receives comparatively less insolation as compared to tropics. Now why this happened? Because of the angle of incidence, because we do not have a earth like straight away, as you will see up the surface of the earth, so there is inclination, right? Because of that inclination, the equator is not straight towards the vertical rays that are falling on the earth. The second is the cloud cover. The cloud cover is maximum at the equator as compared to the tropics. And the third is rain and humidity. So there is sort of humid climate that could be seen on the equator. One important point that they have mentioned, that even at same latitudes, different insolation could be seen. And like at land or sea, because of the concept of land or sea breeze, right? Okay. Then we have heating and cooling of the atmosphere. Now these terms should be clear to us. The first is the conduction. So what is conduction? The transfer of heat when two bodies of unequal temperature are in contact, okay, until attain same temperature. So air in contact with the land heated. So what is the idea basically? Let me tell you. So this is the earth, now this is the surface. So as insulation, solar ins as there is insolation, simply solar radiations falling on the surface of the earth, so surface will get heated up. But after it, when the surface, the air above the surface, when that surface will heat up the air above it, that this process is known as conduction. So this is what they are saying, the transfer of heat when two bodies of unequal temperature are in contact, and they will be in contact till they will attain the same temperature, right? So air in contact with the land heated, they heats up the lower layer in contact with it. Okay, so lower layer, नीचे सर जो उसके सरफेस के पास वाली लेयर है उसको वो हीट अप करेंगे. देन वी हैव कन्वेक्शन. ये बेसिकली फिनोमिना गैस में लिक्विड मीडियम में देखा जाता है. तो अब वो वाला जो मीडियम हीटेड अप, मतलब अब हमने जैसे कंडक्शन देख लिया कि सरफेस हीट हुआ, अब उसके ऊपर की एयर हीट अप होगी. अब जो उसके ऊपर की एयर हीट अप हुई है, वो उसके ऊपर जो एटमॉस्फेयर होगा उसको हीट अप करेगी. तो जो वर्टिकल हीटिंग है एटमॉस्फेयर की, उसको हम बोलते हैं कन्वेक्शन. एंड देन वी हैव एवेक्शन. Now this is vertical heating, convection. Advection is known as the horizontal heating. So transfer of heat through horizontal movement of the earth. This is advection, sorry. Then we have the terrestrial radiation. Now what are these? The reflected back one. The reflected back rays from the earth's surface. Now earth after heated up, it radiates energy to atmosphere in long wave form. So when it's heated up, what it do? It basically radiates the energy back. And this is the entire chart which is given like about the heat budget, how these things work on. And we need to understand this chart in order to understand how this entire system of insulation and terrestrial radiation works. So there's the idea that there is incoming solar radiation. So the rays which are coming from the sun, for example, they are in 100 units. So what happens basically, 35 of them are reflected back and 65 are absorbed. Yes. Now from that 35, 27 are reflected by the clouds and 2 by snow and ice that is present. And the one which is absorbed, out of 65, 14 units are absorbed by the atmosphere and 51 are absorbed by the earth's surface. Now note down this 51 here. अब देखो क्या हुआ, 100 आई हमारे पास, दो दो काम हुए उसके साथ. सबसे पहला 35 तो रिफ्लेक्टर बैक होगी, किसने की वो इन्होंने बता दिया है, वो इतना इंपॉर्टेंट नहीं है. एब्जॉर्ब वाले पे आओ. 65 एब्जॉर्ब हो गई, 65 एब्जॉर्ब हो गई, उसमें से 14 किसने एब्जॉर्ब की, एटमॉस्फेयर ने. 51 किसने की, अर्थ सरफेस ने. अब जैसा कि हमने पढ़ा था टेरेस्ट्रियल रेडिएशंस क्या होती हैं, अर्थ पे जो हमारी इंसुलेशन आई है, सोलर रेडिएशंस आई हैं, वो रिफ्लेक्ट बैक हो रही हैं. तो अभी 51 से हम रीड आउट करेंगे जो टेरेस्ट्रियल रेडिएशंस है. तो आउटगोइंग टेरेस्ट्रियल रेडिएशंस कितनी है, 51, बिकॉज दीज आर द वन विच रीच द अर्थ सरफेस. वी वोंट बी कंपेयरिंग इट विद 100 बिकॉज वो 100 ऑल द वे अर्थ सरफेस पे नहीं है, सिर्फ 51 अर्थ सरफेस पे आई है. तो अब ये जो आउटगोइंग टेरेस्ट्रियल रेडिएशंस है, दीज आर 51. 17 एस्केप टू द सरफेस. अब 17 surface पे चली जाती हैं, whereas 34 are again absorbed by the atmosphere. So you could see the phenomena कि 17 तो वापस ही चली गई, like they strike the earth surface and they reflected back like that, but 34 absorbed by the atmosphere. Now here this 34 is absorbed by the atmosphere and this 14 is absorbed by the atmosphere. So how much of the total radiations, whether it's solar or terrestrial, the atmosphere absorbed, that is 48 units. Okay, so 14 plus 34, right? So these 48 units are absorbed. So total radiations that are going back to the space are the one which is absorbed by the atmosphere, that is 48, plus 17 which are done by the terrestrial radiation when they hit up the earth. So this is 65 units. So the radiations which are going back to the space are 65, right? So now we have the variations in the budget. So this is the idea that they're providing. Before that, this is one point that you need to know, that is albedo. What is albedo? That is the reflected amount of radiations. So we don't say it, these are the reflected amount of radiation, that this is albedo. Simple. जैसे solar radiations के लिए हम simple use करते हैं insolation. Okay. So variation in the budget. So surplus और deficit कब होगा, देखो अब इन्होंने इसको स्पेसिफिक पॉइंट से समझा है. सरप्लस कहाँ पे दिखने को मिलता है, सरप्लस क्या होता है बेसिकली, व्हेन देयर एडिशनल, yes, when there are additional amount of these radiations. So this could be seen between 40° north and south, tropics and subtropics, whereas there is deficit, like the इतनी radiations नहीं आ रही है जितनी ज़्यादा reflect back हो रही है. So that is deficit. So this could be seen near the poles. तो हीट रिडिस्ट्रीब्यूशन पोलवर्ड्स, अब कैसे होता है ये, अब अगर यहाँ पे एक जगह सरप्लस है, एक जगह डेफिशिट है, तो हमको एक नॉर्मलाइज तो करना पड़ेगा, तो सरप्लस से डेफिशिट में भेजेंगे. तो यहाँ पे ही हीट रिडिस्ट्रीब्यूशन का काम आता है, जो कहाँ पे होता है, पोल्स की तरफ, क्योंकि वहाँ पे डेफिशिट है, बाय विंड्स एंड ओशन करंट्स. Okay, now we're done with that topic. Now we have the next topic, that is temperature. Now factors which are controlling the temperature distribution. Now the temperature is distributed across the surface, like there are very much variations in the temperature. So how this temperature, what are the factors which are controlling this temperature distribution? So the first is latitude. So your insulation that varies with latitude. Now how this happens? Now we also read about the part of the angle of inclination of the rays. So that is the reason that plays in latitudes. The latitudes like which are away from the equator, they'll face a less insulation, right? Then we have altitude, that means height. सो हाइट का फैक्टर कहाँ से प्ले होता है देखो, वी नो दैट फंडा अबाउट दैट, अभी हमने कन्वेक्शन, सी वी स्टडीड थ्री ऑफ द फिनोमिना, दैट इज कंडक्शन, कन्वेक्शन एंड व्हाट्स द थर्ड वन, सी वी रीड दिस, कंडक्शन, कन्वेक्शन एंड एडवेक्शन. कंडक्शन क्या बोलता था, जो सरफेस होगा फिर वो हीट अप करेगा अपने ऊपर के. अब ये वाला जो फिनोमिना है ये कम पड़ जाता है, मतलब इसका इम्पैक्ट कम पड़ जाता है व्हेन देयर इज, या देयर आर माउंटेन्स, व्हेन देयर आर माउंटेन्स, बिकॉज दैट सरफेस डिडंट गेट हीटेड अप. तो वो कैसे वो, यस कैसे वो कंडक्शन वाला पार्ट लेकर आएगा, कन्वेक्शन तो दूर हो गया, ठीक है. Now distance from the sea, that's also because the land which is near the sea, there we could not see the more what to say, yes, yeah, more impact of the temperature, whether it's cold or hot. Then we have air masses and ocean currents. So there's one example that warm air masses are there, so there will be higher temperature, right? Then there is one concept of isotherms. So isotherms are the lines which are joining places which have equal temperature. So these are imaginary lines which are drawn on the basis of the places which have the equal temperature. Generally they are parallel to the latitude, but they could deviate. And this deviation is mostly seen in January, then in July. Especially we could see this in northern hemisphere. Now what is one of the reason of them? Because the funda of land and sea. In southern hemisphere there is less amount of land which is present. There are more amount of sea. And sea जहाँ पे present है वहाँ पे as we said that temperature में इतनी variation देखने को नहीं मिलती है. So January में वो बता रहे हैं कि isotherms deviate to the north over sea, sorry, isotherms deviate to the north over ocean and to south over continent. So what happens basically, the idea that they're providing us कि जहाँ पे land है वहाँ तो वो north की तरफ जा रहे हैं ऐसे like this, and where there is sea they are going downwards. Okay, because of the presence of warm ocean currents they are giving us example. जो Gulf stream है और North Atlantic drift है वो क्या बनाते हैं, एक एन ए, वो क्या करते हैं, वो NaO को गर्म करते हैं. व्हाट इज दिस NaO? दैट इज नॉर्थ अटलांटिक ओशन को गर्म करते हैं. एंड isotherms like they bends towards the north. जुलाई का फंडा उन्होंने समझाया है, वो जनरली पैरेलल होते हैं लैटिट्यूड के. इक्वेटोरियल ओशंस रिकॉर्ड वार्मर टेम्परेचर मोर देन 27 डिग्री Celsius, and this is the idea that they're providing. You need not to learn this entirely, but you should know a brief idea that how things are changing. One difference that we could see that यहाँ पे generally parallel in latitudes के इतना deviation नहीं है, बस एक दो जगह deviation है, ठीक है. This is the star performer of today's class, that is temperature inversion. Now what is temperature inversion? सबसे पहले inversion is something which is different from the nomenclature. So वहाँ पे nomenclature क्या होता है, नॉर्मल चीज़ क्या होती है, दैट इज द नॉर्मल लैप्स रेट. तो नॉर्मल लैप्स रेट क्या बोलती है कि जैसे जैसे हाइट बढ़ रही है वैसे वैसे टेम्परेचर गिरता जाता है. बट टेम्परेचर इन्वर्जन का जो आइडिया है वो ये कहता है कि टेम्परेचर बढ़ रहा है जब ऑल्टीट्यूड बढ़ रहा है, तो इसके लिए एक आइडल सिचुएशन है जो हमें चाहिए होती है, एंड दिस इज द आइडल सिचुएशन. Ideal situation or temperature inversion is long winter nights that should have a clear sky and still air. Means winds and all shouldn't be there. Now what is the reason of it? Because heat of the day radiates off during night. Now what all heat was given during the day at these places, they are radiated off during the night. And early morning the earth cooler the air above it. Now the earth which is present above it, that is cooler, and there is a trap basically which is formed. For example, there is a cool air then there is warm air, and then again there is cool air. So due to this air drainage, this happens. So cold air denser than warmer air and it flows downhill. वो तो उन्होंने आइडिया समझा दिया, तो ये बेसिकली जो होता है. And what this basically helps us to protect the plants from the frost